Welcome back everybody, and right now what we're going to do is we're going to navigate through the Nmap and see different types of options that we didn't cover and see what kind of output we get using those options. So if you open up simply Nmap right here, you will see some of the options that we did use, such as for example -F for fragment packets, but we didn't really see the output of that scan. So if you simply just go Nmap and then 192.168.1.6, which is the IP address of my actual Windows 10 host, press here enter, it won't take too long to actually finish, but we're going to see whether there is any types of difference between this scan and between the scan where we actually fragment our packets and split it into smaller ones. So right here we can see 70% done. We get it all finished in 15 seconds, only one port open, and it is this port right here. But right now let us clear the screen and let us use -F option and specify the same IP address, which is 192.168.1.6, press here enter, and let's see whether there is any differences between the outputs of these two scans. We can use upper arrow in order to see how much it takes to finish. As we can see, the output is rather the same, just this scan has finished in 5 seconds less, or in 10.41 seconds. Now, there is no difference between the outputs, it is rather the same. Just what this option, as we said before, does is it helps us bypass the actual firewall by fragmenting packets into smaller packets. Now, let's see the more detailed or more advanced use of this option with the --mtu. Now, if you simply just type something like this, nmap --mtu, and then for example specify 8, now don't worry, I will explain everything, just let me type it, and then the IP address, which is 192.168.1.6, this is the more advanced option of actually fragmenting packets, because using the MTU, which stands for maximum transmission unit, and the number 8 simply specifies that you can send maximum 8 bytes. So what this actual command allows us to do is manually decide what is the maximum actual size of packets that you want to send. In our case, we set that to be 8 bytes with the --mtu, which once again stands for maximum transmission unit. And if you simply just press your enter, we'll get the same output as before, just our packets will be fragmented up to 8 bytes. So you can see it does take a little bit longer to finish this scan, as with the simple -F option, we actually finished the scan in 10 seconds. And this one actually took 15.12 seconds to finish. Okay, so that is what we can do with actually fragmenting packets. Now this can be useful once you actually need to bypass a certain firewall rule, which basically says that they do not deal with larger types of packets, so you actually need to fragment everything into a certain size in order to be able to scan. Now let's take a look at another option, which is -D. If you simply just open the Nmap menu, you should see -D somewhere around here. As we can see, here it is. It is a decoy, as it says cloak a scan with decoys. What that means basically is that it will send packets from random IP addresses and random ports, as well as random types of packets. Now that is only there in order for us to disguise in some different traffic, so it will all look like a normal traffic to a certain target machine. So for example, they're getting packets from all kinds of IP addresses. In those packets there are also some real packets that are from our scan. So in order to actually do that, we can simply just type nmap -D, so capital D, and then if you simply just type rnd and then 2 dots, and then you simply specify 20, this will basically send 20 different packets from 20 different IP addresses, I believe, and then you specify the IP address that you want to scan, which is in our case, once again, so here it is. Yeah, we can't really specify that. This is an actual IP address that we need to specify, so not 20. We can simply just type right here, for example, Google DNS servers, so 8888. And we can see right here, the scan will seem that it's coming from the actual DNS Google servers. So this scan has finished. We got the same output as before. We're actually sending random packets from this IP address, and we're scanning this machine right here, which is Windows 10 machine. So make sure that you add -D and then RND, 2 dots, and then 8888. Or you don't really need to specify 8888, you can specify any IP address that you want. As we can see, this is on 74%, 75%, but the actual output will be rather the same for all of these scans. They are simply just there for the variety. Since I don't really have any type of firewall or any type of rules to actually bypass, the output for all of these scans will be the same. So let us see, 85% right now. Okay, so here it is. As we can see, it finished everything correctly. It seems like it actually scanned this IP address, which we didn't want. So let us open our Nmap menu right here and see -d decoy. So what if we simply just specify the same command without this? Or even better, we can open the manual for Nmap right here. We can go all the way down and find the option, which is going to be explained in more detail. So just scroll all the way down. You can see this is a huge file consistent of everything that Nmap is capable of. And what we're going to do in the next video is we're going to go over this file and check out these different types of scans, which are mostly going to be these scans right here, such as, for example, TCP SYN scan, TCP connect scan, UDP scans, and so on and so on. Now, we are not interested in that at the moment. What we are interested in is in the -d option. So let's scroll all the way down and let's see what type of actual syntax we need to specify. This is -t. Okay, so here it is. Cloak a scan with decoys, as it says, it causes a decoy scan to be performed, which makes it appear to the remote host that the host you specify as decoys are scanning the target network too. Thus, their IDS might report 5 to 10 port scans from unique IP addresses, but they won't know which IP was scanning them and which were innocent decoys. Right, this, or while this can be defeated through router path tracing, response dropping, and other active mechanisms, it is generally an effective technique for hiding your IP address. Separate each decoy host with commas, and you can optionally use ME as one of the decoys to represent the position of your real IP address. Let me just see right here. So here is the RND. You can also use the RND to generate a random non-reserved IP address, or RND number to generate number of actual addresses. So I'm not really sure why that didn't work then, because we did specify RND and then, for example, 20 for 20 random IP addresses. Let us try it once again. So nmap-d RND 20 and then the IP address. Okay, so it seems that it works right now. It could possibly be that in the previous actual scan, what I did is that I actually separated this with a space between the two dots and the 20. Therefore, it actually counted this 20 as an IP address and it couldn't really scan it. Let us see if that was the problem. So if we add space right here, yeah, that was the problem. So as it says right here, failed to determine route to this IP address, because it actually, if you add a space, it will consider this an IP address and not a part of this command right here. Okay, so what a normal command looks like is this right here. Make sure to not split this, okay? So that would be about it for this actual option. Let us continue with a different option, which, if we open up our Nmap menu, would probably be the spoofing of source address or source IP address. So we can simply just type something like nmap-s and then 192.168.1.15, and if we specify two actual IP addresses, it will say, warning, if -s is being used to fake your source address, you may also have to use -e interface and PN. Okay, so if you use -e and ETH0 and -pn, press here enter, cannot assign requested address, but it is performing the scan. So we use the -e option for our interface, and you can check out which interface you're using simply just by typing ifconfig in your command, or pardon me, in your terminal. If you're simply running over a wireless network, your IP, your network adapter will be different name, therefore you will not be specifying ETH0, but if you're using Kali Linux over cable connection, you will specify ETH0 just as I did. And this -pn option basically stands for bypassing the ping scans, I believe, or something like that. It will be an option that actually allows us to scan the host without pinging it or something like that. Let me see -pn right here. -pn 3 total host is online. Skip host discovery. Yeah, this is in case our actual host or our target machine is blocking our ping requests. Therefore, we will treat all hosts as online and we will skip the pinging of that specific host, because if we do ping it, that host will actually appear as offline in case it is blocking our requests. Okay? So simple as that. So this is the actual faking of a source IP address. So once again, you need to use -e for the interface and -pn for the ping requests. Okay? Or for disabling ping requests. Now, another small advice, once you actually scan a black box target, and by black box I mean you don't know anything about it, you want to actually get caught, or pardon me, you don't want to get caught by security systems, so your best thing to do is spoof yourself and try all these options at once, because even if you get caught, you will get caught with spoofed MAC, spoofed IP address, and so on. Therefore, you can just spoof it once again for the next scan, and security systems will not be able to recognize you as a previous attacker. Okay, so basically that will be about it for this tutorial. We saw some different options in this video, such as /MTU, which stands for maximum transmission unit. We saw how we can actually determine which size of packets we're going to send. We also saw how we can actually create a decoy, which is going to send packets from random IP addresses. In our case, we used random and then 20, so from 20 different IP addresses. And we also saw -C option, which allows us, or pardon me, -S option, which allows us to actually spoof our source IP address. Okay, so that will be about it for this tutorial. And in the next tutorial, we're going to cover more options, more advanced options with Nmap using the Nmap manual. And after it, we're going to finish our Nmap section. So hope I see you there and take care. Bye.